So we've talked about vertical asymptotes, and in the previous example where we were looking at the reciprocal function, we noticed that the vertical asymptote occurred at x equals 0. In general, vertical asymptotes are located at values of x that are zeros of the denominator, but not zeros of the numerator. Wait, I said that wrong. Zeros of the denominator, but not zeros of the numerator. So if we have a function, and let's just look at one. So if we have x over x squared minus 1, we're going to think about what values of x make x squared minus 1 equal to 0. So of course, we can solve that. We're going to get x is equal to positive and negative 1. As long as these values of x do not also make the top of that fraction equal to 0, then we have a vertical asymptote where x is equal to 1 and where x is equal to negative 1. So this particular function has two vertical asymptotes. Now for another example, g of x is x minus 1 over x squared minus 1. Okay, and it's helpful to factor when you're looking for asymptotes. So I could have done that in the first case, and let me go ahead and do that in this situation. Factoring that denominator would be x plus 1 and x minus 1. And then I'm thinking about what's going to make x plus 1 equal to 0. I'm not going to worry about x, come back, minus 1 equal to 0. Because x minus 1 is a factor of the denominator and the numerator. And so if I solve this for x and get positive 1, that is a 0 of the bottom and the top, so that one's not a vertical asymptote. This graph would only have one vertical asymptote at x equals negative 1. Now we also need to talk about where horizontal asymptotes occur. Where does the graph kind of level off? And to do that, you look at the degree of the polynomials in the top and the bottom. And this is what you look for. First thing, if the degree of the top is less than the degree of the bottom, then y equals 0 is the horizontal asymptote. You don't have to do any work, you just know y equals 0 is the horizontal asymptote. If the degree of the top is equal to the degree of the bottom, then your horizontal asymptote is going to be the equation y equals the lead coefficient of the top over the lead coefficient of the bottom. And of course, if that reduces, you'd want to reduce that. The third possibility is that the degree of the top would be greater than the degree of the bottom. And that's the case, there is no horizontal asymptote. So, examples where we're looking for horizontal asymptotes. Suppose I've got a function g of x, 9x over 3x squared plus 1. The degree of the top function is 1, the degree of the bottom function is 2. So since the bottom has a greater degree than the top, then y equals 0 is our horizontal asymptote. Another example, suppose we look at f of x, and f of x is 9x squared over 3x squared plus 1. The degree of the numerator is a 2. The degree of the denominator is a 2. So since those two numbers are the same, then our asymptote is going to be y equals lead coefficient over lead coefficient. So y equals 3 is our horizontal asymptote in this case.